Okay, good morning everyone. So today we are going to continue with our class questions, the practice questions from the last class. So if you remember, in the last class we started with the test 3 materials. We finished question 1. Now the question 2, I ask you that if an interaction is present, the lines on the profile plot will intersect. Is that true or false?
True.
So it's not necessarily that it should intersect. It can intersect, but if it's not intersect, only thing that we need to notice whether they are parallel or not. If there is parallel, we say that there is no interaction. But if they are not parallel, even though they are not intersecting, there still can be an interaction. So we can say this is false. So the idea why it is false, because the interaction if the lines are parallel, then there will be no interaction. But if the lines are not parallel, let's say if we get one line like this, the other line like this, but they are not crossing each other, but they are not parallel, it means there is an interaction. Okay, now question 3. What do you think? The true or false? In the logistic regressions, B1 is the predicted change in the probability of success for 1 unit increase in the predictor. There was a questions in your test 2 about the interpretation of B1. Anyone? So in logistic regression, if we interpret in terms of 1 unit increase, then we can say that this is the log odd, expected value of the log odds. This is not the probability. Okay? So this is false. Now in factorial ANOVA, what is factorial ANOVA means? That if we have more than one predictor in our model, this is called a factorial ANOVA. Yes, thank you Priyanka and Tanner for your answer. Now factorial ANOVA, if factor A has 2 labels, factor B has 3 labels, there would be two orthogonal main effect contrast for factor B. Is that true or false? There was a questions like write down the compact and the augmented model. Some of you make a mistake. So in your test 2. So what do you think that if we have factor has 3 labels, how many orthogonal main effect contrast we should get? Three labels, how many contrast we should get? Okay, let me see what you said. So Anna says 6. We are looking for only for the main effects for the factor B, not for A and B. So Jack says 4. Okay. 2. Okay. So it should be 2 because we have here, you can see that factor B has 3 labels. So for 3 labels, we know that we can create 2 contrast coded variables. So we should have 2 labels, 2 orthogonal contrast code. Is that clear? So it cannot be 6 because we are only considering factor B. So this is true. Now question 5. Power is the probability of rejecting the null hypothesis when it is true. Sorry, when it is false. Is it true? What is power? The power is probability of correctly rejecting the null hypothesis. So what do you think? Are you going to reject the null hypothesis correctly? So the chart says is false. Okay, look at this. I said that the power is the probability of rejecting the null hypothesis correctly. So what we are doing here, we are rejecting the null hypothesis when it is false. So we are rejecting it correctly. So this is true. So this is the power. If the null hypothesis is false, we are rejecting, this is called the power. So this is true. Now, question 6. There is an interaction in a two-way ANOVA model. Okay? When the two factors are associated, both factors have significant main effects in the model. The difference in the two means between the two categories of one factor varies among the categories of other factors. Or the sum squares of the error for the augmented model with interaction is the same as the sum squares of the error for the compact model for the model without interactions. Which one actually, I am asking actually what is the interpretation of the interaction effects in ANOVA. So this is just the definition. What do you mean by the interaction effects? Interaction effect means if we see that there is a change in the relationship between the response and the one predictors, depends on the levels of the other predictors. So this is called the interaction effects. So here, what is the change in the response? The average or the true means or the average we can say. The difference in the average of the two categories of one factor that depends on the levels of the other factors. So this is what the interaction effect is. Interaction effect means if we change the levels of one factors, the difference in responses changes based on the values of the other factors. So this is what we mean by the interactions. Two factors are interacted means whenever we change the levels of one factors, the responses change based on the values of the other factors. And this is what we mean by the interaction. So in this case, which one do you think that it is true? A, B, C or D? C. Thank you for your answer. So C, you can see that it tells us the true mean differences between the two categories of one factors varies among the categories of the other factors. Now the p-value for testing HO beta 1 equal to 0, HA beta 1 is not equal to 0 in logistic regression is 0.001. This indicates that which one is true? So B. Thank you for the answer. So obviously B, because if the null hypothesis, p-value is small, so we reject our null hypothesis. That means we have strong evidence that beta 1 is not equal to 0. Okay. In ANOVA, a main effect for a factor A is observed when. So there was a question same as like this in your test too. What does the main effect tells us? So what do you think? Which one should be the true? The main effect of a factor. If the main effect is significant, what does it mean? Or if the main effect, what does the main effect tells us? So we know that interaction effect tells us if we change the levels of one factors, the mean responses changes depends on the values of the other factors. Now what is the main effect tells us? The main effect tells us the mean responses changes or differs for at least one level of one factor when we take the average based on the other levels of the factors. So this is the main effect. Is that clear? So which one do you think? So the NR says B. So the change in the main response for at least one no. So B says the change in the main response due to factor B differs for at least one levels of the factor A. No. Because we are not looking at the changing in the levels of the another factors. We are looking for the what is the average change, or we are looking at the whether there is an average change in the response by changing the levels of one factor when we take the average over all other factors in the model. So Jack says this is, thank you, it should be C. So the mean response differ for at least one level of factor A when we average over the levels of the other factor. So here the left factor B. Now question 9, which of the following plots indicates a violation of constant variance assumptions? We have 4 different plots. Plot D. Thank you for your answer. So this is plot D. So the plot D we can see now. There was a question in your test 2, okay. In question 3B, that okay, whether there was a violation in the constant variance. Most of you just say that no, there is no fan shape, but it's clearly, if you look at the solutions here, I think only 1 or 2 got the correct answer. Fan shape does not mean that it should be just like this. It can be like this is also a fan shape. So if you look at the solutions here, let me share with you the screen. So look at this. This is a fan shape, clear fan shape. If you do a curve like this is a 0 line, okay? Now if you do a curve like this, you can see that there is a fan shape like this, okay? So this clearly indicates that there is a violation of the constant variance assumptions. You can see that if the plots of the residual, but the error is not apparently constant, A low humidity, there is low variability due to few observations, the average is high, so it tapers going off the humidity like this. And you can see here, if you look at this is the one that I showed you. So you can see it's going up here. Okay, now. So that's the end of our class questions for today's class. So I uploaded another set of the questions that you told me that we need. If you go back here, another set of practice problems, and there is some data set relevant to this. So in these questions we have ANCOVA, we have some orthogonal contrast, but in your test 2 I can say that most of you, almost all of you get right in the orthogonal contrast, that how to write the contrast. I didn't see any problems in your orthogonal contrast, but most often you miss some other parts. Okay, so let me go about this orthogonal contrast one. So the scenario and the data for this portion of the test comes from another book. So a consumer organization studied the effects of age and gender of automobile owners on the size of the cash offer for a used car by utilizing 12 people, 6 males and 6 females in each of 3 age groups, who acted as the owner of a used car. A medium-priced 6-year-old car was selected for the experiment, and the owners solicited cash offers for the car from 36 dealers selected at random from the dealers in the regions, and the dealers are randomly assigned to each of the owners. And the data are provided this one, and the cash offers is the amount offered by the dealer for the car in hundreds of dollars, age group of the owner, and the gender of the owner. Now, the first questions I ask you, it is thought that both gender and age influence the amount of the cash offer received by the dealer. It is also believed that there is an interaction between gender and age. Now, what would be your compact and the augmented model in this case? Model C and the model A. Can anyone tell me? Model C. So model C are simple models. Okay, so it is yi equal to beta 0 plus epsilon I. Now model A. Can anyone tell me what will be model A? That's very important thing you have to know. Yi equal to what? How many variables we have to create? Or contrast coded variables we will get? Then you can think of how many predictors we will have total. So let me see what you said. So beta 1 x1, beta 2 x2, beta 3 x1 x2. Okay. Now, okay. Charles says that okay, beta 1 x1, beta 2 x2, beta 3 x3, and then Jack says beta 1 x1 plus beta 2 x2. Okay. Priyanka says 2 contrast code. Okay. Now, all of you get partial right, but not exactly. So look at this. First of all, that's very important. That's why I am reviewing very carefully. How many labels do you have for the age? 3 labels. So we know that if we have 3 labels, we will get 2 contrast coded variables. Okay? For the main effect of age. How many labels do you have for the gender? 2 labels. So we're going to get 1 contrast coded variables for the main effect of gender. Now we get three variables. One for age, we get two main effects, contrast coded variables. Gender we get one, so three. Now interaction, so we can say x1, x3, x2, x3. Okay? So you're gonna get five variables here. So three of them will be the contrast coded variables for the main effects, and the other will be for the interactions. So yi, and keep in mind the parameters here. So there was also another questions in your. This is simple questions, but most often the student make mistakes. So I will tell you. Okay. x1, x2, x3, x4, x5, and epsilon I. Okay. So this is your beta 0. Now this is your beta 1. X I1, beta 2, X I2, beta 3, X I3, beta 4, X I4, beta 5, X I5, and epsilon I. Okay. Now, one thing you can notice, how many parameters do you have in the augmented models? Can you tell me? Six parameters. Now, that does age go in columns or gender in rows. We are not doing the column and the rows here because this is the data set. Okay, so these are the two-way contingency tables. So in the data set, we don't care about the rows and the columns because always the observations in the rows and the columns the variables in the data set. And if you look at this data, I'll show you the data because this is the data frame. Now, six parameters. Keep in mind, we need to consider the intercept as the parameter. So we have six unknown constant. And there was a question in your test that how many parameters do we have? So some of you just make a mistake. Some of you just say that we have 19 contrast coded variables. But you miss the intercept. Intercept is also a parameter. I said the parameters. I didn't ask the contrast coded variables. For example, here we have 5 contrast coded variables but 6 parameters. Now you need to define all these things. So we can say here beta 0 is the grand mean. And we can say beta j in general is the change in the mean response for contrast coded variables xj then you can say that, okay, x1 and x2 are the main effects contrast for age X3 is the main effect contrast for gender, and the remaining XJ are the interaction contrast for age and gender. Okay, so let me see what you put here in the chat. Okay, so this is just a two-way ANOVA, not a contrast code situations. So this is a two-way ANOVA, but we are creating the contrast coded, because you know whenever we have the, no, this is not the ANOVA. So sorry, I missed that. So this is a two-way ANOVA, but this is not a contrast coded that we are writing, because this is what we are, because we know that whenever we have a categorical predictors, we make a contrast for each of the labels. But this is just a two-way ANOVA. But later on in these questions, you will see that we are looking for the contrast coded in the next part of this question. Question 2 part. Thank you, Jack. Now, is there evidence of a main effect of gender and age? Now, if you go to this data set here, if you go ELC, you can see we have the data here, the CH cache offer. The download this data, open it into the JUMP. So we open this data set into the JUMP here. So this is our data. So in this data we have the variables here. The cache offer is our response variables. Based on the two predictors, one is the age, another one is the gender. Now I would like to fit a models and observe the relationship between these. We are also doing the interaction effects, okay? So why are the two interaction variables? Okay. So how many labels do you have? So how many contrast coded variables do you have? So x1, x2 and x3, okay? Now how many interactions we can say? x1 and x3, x2 and x3. That's how we made the two interactions here. Now, because the one is the reference category, you know, it always goes to the reference, and you can see when you feed the models, you will see these things. So cache offer is our response variables. Now age is our factor variables, one. Another one is the gender, and we are looking for the interactions between age and the gender, the cross product. And then you feed the models, okay, maybe these are shared one. So if you go and look for the result, you can see here. So can you see here, it's clear here that why we put the two contrast interactions here, you can see. Now, we look at the effects. So effect test, because we are looking for whether the main effect is significant or not, interaction effect is significant or not. Now, based on this, what can we see here? Age is the only significant predictor. Now the gender and the interaction effect is not significant. If you look at the p-value here, they are highly insignificant. Now if you go back to your, so is there evidence of a main effect of gender or for age? So we can say that the p-value for the main effect of age p-value the main effect of age is less than 0.001, triple 001. Okay, now indicating that a significant main effect. So this implies that there is a difference. So what is the main effect tells us? We know that there is a difference in the average cash offers. Because the cash offer is our response variables for at least one age group. When averaged over the gender. So keep in mind here, actually I can ask two questions. I just ask one question. So for your questions, that part is fine. Until this part is fine. But if I ask you what does the main effect tells us, or what is the interpretation of the main effect, this is the interpretation. So we can see there is a difference in the response. So in our case, the difference in the average cash offer, which is our response variable, for at least one age group when averaged over the other factors. What is the other factor? The gender. Now this is significant. What about the gender? Now the p-value for the main effect for the gender is equal to 0.1416. So we can say there is insufficient evidence for a difference in average cash offer received by the two genders when averaged over different ages. So this is the, just for your part, this answer is enough. We can just say that the main effect of the gender is this, so we don't reject our null hypothesis, so we can say insignificant main effect. But you can also, this is the interpretations. Okay, now what about the interactions one? Now if you look at the interaction effect, we have seen that the p-value for the interaction effect is not significant. So we can say that the p-value So what is the p-value for the interaction effect? 0.3597. 0.3597. 3597, indicating an insignificant interaction effect. Insignificant interaction effect. This implies that there is insufficient evidence to indicate a different effect on average cash offer received due to age for two genders. Now next part is generate profile plot for the three effects tested. Do they support your conclusions? Explain this. Okay, so this is part D. Now, how can we generate the profile plot? So if you look at this, so we didn't generate the profile plot. Here we have this one. So let me show you one more time how to generate the profile plot. You can go to the top red triangle and factor profiling. Now, since we have the interaction plot as well as we have the main effect, so we need to select two times. One, profiler will give you the profile plot for the main effects, and interaction plots will give you the interaction profile plot. So profiler. So this creates the profile plot for the main effects. Okay. Now, first explain what do we see here. Do you see any differences in the profile plot for the age? And what do you understand by these differences? Can anyone tell me? So, is it that middle age had the greatest associations? Yes. Thank you. Thank you for understanding this part. So we can see that this indicates that the higher average cash offer made to the middle age. It's clear because this is the two, the middle age. Then for either young or elderly one. So there is a strong visual evidence that for a main effect of the age. Is that clear from this profile plot? So we can see that middle age indicates the higher average cash offer compared to the younger one and elderly one. So this indicates that there is a strong visual evidence of a main effect of age. Okay. So if you go to the you can copy graph and put it in our okay. So this is how I put the graphs. Now we can say that the main effects here the profile plot for age indicates a higher average cash offer mate to the middle age. So higher average case of are made to the middle age than for either young or elderly. So this indicates, so this tells us that there is a strong visual evidence of a main effect of age. Okay. Now what about the profile plot for the gender? What do we see in the gender case? What do you think? So if we look at the gender, we can see their average is almost same for the both levels. So for male and the female, that means the profile plot for the gender indicates about the same average case of are made to the males and the females. About the same average case of are made to the So if there is the same average case of R, so we can see there is no visual evidence for a main effect of gender. So therefore, there is no visual evidence of the main effect of gender. Okay. So Tanner says weak relationship. We are not looking for the relationship. We are just looking for the whether there is an effect of the main effect, whether there is a significant main effect based on this profile plot. So we don't talk about whether we have weak or strong association here. We can just say that whether there is an effect of gender on Keshavar or not when we change the levels. Now, next one we are looking for the interaction effects for the gender. So here is our interaction profile plot. So this is actually the interactions on the genders with the different levels of the age. Okay. Now what do you think here? The interaction effects. So do you see any changes in the average case of R when we change the levels of the age as well as the genders? We can see that three of them are almost same parallel lines. Okay? Parallel means this is the average case of R for the age group 2. Okay, so middle age. When the gender is male and when gender is female. So we can see there is no changes in the average K-SHOFR when you change the labels of the genders. So same thing here, same thing here. We can see slight variation here, but it's not enough to provide a significant difference. Is that clear? What I mean by this? So this is the nice plot I created in another graph. So I am just putting, sorry. Let me go back to our questions. So based on these questions, we can say that the interaction plot indicates that the change in average K-SHOFR going from male to female is about the same for 3 age groups. So this is what the interaction effect says, that change in the response is same for the 3 different age groups. So they are roughly horizontal. So we can say that the interaction plot indicates that the change in average K-SHOFR So the change in average K-SHOFR going from male to female is the same. So try to understand these 3 very carefully. That would be very helpful for you. So our time is up. So next class I am going to finish all these questions here. So there will be an ANCOVA questions, as well as we have the 2 keys test, as well as we have the orthogonal contrast code in the part 3. So we'll do these things in the next class. And this will be our end of the review. So next class I also want to go for online instead of coming to the class. So we'll do the online class in the next class. And those who didn't do the course evaluation, please do it, because our deadline is May 4th, I think. So you have still time. And if you have any questions about your project, you can come and see me in my office hours today. We can go over this, or any other question, feel free to reach out to me. And if you follow very carefully all this practice problem, you should do very well in your final exams. Okay, let me see what you said here. Okay. Any questions? So the next week we have Monday, I have office hours. Tuesday I don't have, because the Tuesday I have the faculty meeting, but I don't know exact timing. But if you want to come anytime, just make an appointment with me on Tuesday. This is the reading day. So I'll not hold office hour, but from Thursdays, from Wednesday, I'll have final exam for the other courses, so I'm not holding any office hours from Wednesday. So if you want to make any appointment, you can make an appointment and come and see me before your final exam, but there will be no formal office hours when the exam will start, because I'll be proctoring in many exams for my different courses. So unfortunately, I cannot give you exact timing, but you can still let me know if you want, and we can make one-to-one meeting Zoom and we can go over this. Okay, so I believe you don't have any questions. So have a nice weekend for everyone. Hope to see you on Monday again. So bye bye.